Good morning students. And next topic is effect of cascading single tune amplifier on bandwidth. So already we have seen single tune amplifier. Now let's see the cascading of single tune amplifier with the effect of bandwidth. So requirement of overall gain can be achieved by simply cascading these several identical tuned amplifiers. Okay, that means we have to get the gain value is higher. For that purpose, we are going to cascading the several identical tuned amplifier. So the overall gain is the product of voltage gain of the individual stages. So overall gain is nothing but the multiplication of voltage gain at individual stages. At the same time, high voltage provides a narrower bandwidth than for a single stage. That means high voltage provides a narrower bandwidth than for a single stage. Okay. So when compared to single stage, multi-stage, that is cascading tuned amplifier provide a narrower bandwidth. Consider a n stages of single tune amplifier connected in cascade. So to determine the overall gain and bandwidth of such an amplifier, the relative gain of a single tune amplifier with respect to the gain and resonance frequency FR is given by. So this is the relative gain of a single tune amplifier already derived in a single tune amplifier circuits. So that is A divided by A resonance equal to 1 divided by root of 1 plus 2 del Q naught the whole square. This is for a single stage tuned amplifier. Now we are going to find out the overall gain for a n stages. So for n stage, A by A resonance power n equal to that power n. It is nothing but we remove that root, we have to substitute 1 by 2. So 1 by 2 means n by 2. The 3 decibel frequency for n stage amplifier is A by A resonance power n equal to 1 by root 2. Okay, so this is second equation. So 3 decibel means is nothing but 0.707. So 0.707 is nothing but root 2. Okay, so now compare 1 and 2. So the equation 1 which is equal to the equation to 1 by root 2. So the root is removed applying 1 by 2. Okay, so squaring on both sides. Will remove this 2. So finally 1 plus 2 del Q E the whole square power n equal to 2. So 1 plus 2 del Q E the whole square equal to this n comes to this side. That is divided by n on both sides. So this n cancel. Here 1 by n is will get. So now let's convert this 1 to this side. So 2 del Q U the whole square equal to 2 power 1 by n minus 1. The squared is replaced in terms of square root. But in a single tune amplifier already we find out the del equal to omega minus omega naught by omega naught. Otherwise omega is nothing but f minus f naught by f naught. Let's substitute this value to here. So for del 2 into f minus f naught by f naught into q equal to plus or minus square root of 2 power 1 by n minus 1. So from the 2 into f minus f naught q equal to plus or minus this denominator f comes to this side is numerator f naught square root of 2 power 1 by n minus 1. So now f2 minus f naught equal to f naught by 2 q 2 power 1 by n minus 1. So f naught minus f1. It is bandwidth is nothing but f2 minus f1, right? So this is f minus f naught is nothing but f naught minus f1 equal to plus or minus f naught by 2 q 2 1 by n. Add and minus f naught. So bandwidth f2 minus f1 plus f naught minus f naught. That is both term is cancelled. So we get f2 minus f1. So f2 minus f1 is that is f2 minus f naught minus f1. To replace this equation 2 like this. F2 minus f naught is nothing but this value. So substitute this value. F naught minus f1 is this value. Right? Substitute this value. Here is f is nothing but this f naught is common. F for higher and lower bandwidth. So we can derive this into two equations. One is f2 minus f naught. Another one is f naught minus f1. So let's cancel these two terms. We get the f2 minus f1, right? So for that purpose only we simplify to write these two equations. So now substitute these two value, and after simplification we get bandwidth equal to f naught by 2 q square root of 2 power 1 by n minus 1. So bn equal to b1 f naught by qe is nothing but b1 into 2 power 1 by n minus 1. That is bandwidth of the single stage. Bn is the bandwidth of multi-stage. So it is obvious that the overall bandwidth is reduced by a factor of root of 2 1 by n minus 1. That is, the overall bandwidth is reduced by a factor of this value. Okay, let's see with the example. For substitute n equal to 2, then b2 equal to b1 into 2 power 1 by 2 minus 1. So value is 0.643 b1. For n equal to 3, the value is 0.510. So the value is reduced. So that the bandwidth is reduced by 643% for stage 2 and 51% for stage 3. Okay, so this is the effect of bandwidth on a cascading single tune amplifier. Is it clear?